Okay, so I want to take a short lecture. This is probably going to be around 5 minutes to introduce everybody to distributions and explain more what a distribution is. So in this lecture we'll be discussing distributions for populations and for samples and showing the relationship between the distribution of each. And so for this, you should understand what a distribution is, what the distribution is for a population versus a sample, and we will apply that information. And so to easily define, or to quickly define distribution, the distribution refers to the spread of scores along a particular continuum. So this is the frequency of particular scores along this continuum. And it's characterized by a boost in the middle, where you have most scores sort of clustering around the middle, and fewer scores along the tails, right? So most of the scores are going to be in the body of the distribution, and fewer scores are going to be in the tails. And this is important to note because this is going to be, the distribution will be used throughout the rest of the class. And so this is where we start getting into testing differences between groups and testing to see where the sample is different than the population and so on and so forth. So this is a very important concept to understand. So first let's talk about the population distribution. Now oftentimes in research, we don't know what the distribution of the population is. And so that's why we sample, is because we can't gain access to the entire population. It's oftentimes impossible, especially in the social sciences. So what we do is we use sample distributions or sampling to identify what the distribution of the population is. So in this case, we're inferring what the population distribution is based on the sample, right? And so if there's a discrepancy between what the actual population distribution is and what the sample distribution is, that's where you have your sampling error. So let's quickly jump into, and that's important in terms of research and understanding how the relationship between populations and sample distributions, and you'll see what I mean in a second. So let's try to understand a population distribution. Say we have, say we're interested in University of Washington Bothell students' grade point average, and we can put GPA for students on a continuum or on a distribution, right? And so to represent this visually, what we have is on the x-axis we have the raw GPA for all of students, and in this case we have a mean of 2.5 and a standard deviation of 0.5. This is not the actual the distribution. This is just an example, so I didn't look these data up or anything. On the y-axis it represents the frequency or the number of students who have that GPA. And so you've seen this before. This is often represented by a histogram. And what we find here is that most people sort of cluster in the middle with a GPA of 2.5, right? So that's the most frequently occurring grade point average. Most of the people have that grade point average. And then fewer people are at the tails. So fewer people have much higher grade point averages, and fewer people have much lower grade point averages. So the bulk of students are clustered in the middle, and that's exactly what a distribution is. It shows the extent to which people are clustered in the middle, and fewer people are in the tails or have different GPAs than average. And so we can do this on a z-score, right? And so this is what we've been doing throughout the quarter so far, is we've been converting raw scores into z-scores. And basically what we're doing is we're standardizing the raw scores, or we're making the raw scores be placed on a scale that can be compared across various types of scales. So this standardizes everything based on a mean and a standard deviation. So what we have here is the mean of 2.5 and then the standard deviation of 0.5. And so when we convert that to a z-score, we now have a mean of 0 and a standard deviation of 1. And that's all a z-score is it's comparing the mean and standard deviation and making that the same and putting that on the same scale. And so this is basically what a distribution is. It's looking at the frequency with which people have various scores along a continuum. And that's exactly what a distribution is. So we're going to be using this idea a lot in class. And so this idea is often used with the bell curve or the normal curve. And so what we can do is we can simply remove the histogram, or we leave it in, but researchers and statisticians know that if you see this little this bell curve here, we know that represents a distribution of scores, and we know that most people are clustered in the middle and fewer people are in the tails. And so it's important to know the relationship between a population distribution and a sample distribution. And so I'm going to give you an example of that quickly. So let's say, for example, we keep the same distribution, right? So we have our population, we know our population. But for some reason, I want to see if my class is different for some reason, right? So I want to look at the sample of my class. So we have the sample of University of Washington Bothell students, and the sample is my statistics class. So I'm trying to see if my students are similar to the population or different from the population. And so what we have is my sample here. And so this is the distribution for the sample of students, right? And so what we try to do is, in statistics, if for some reason we can't get this population distribution, if for some reason we don't have access to it, which is oftentimes the case, what we're trying to do is we're trying to infer the larger distribution of the population based on the distribution of this smaller population. And as you can imagine, and this is where sampling error comes into play, because what happens is if you have a fewer number of people in your sample, you're more likely to not represent the population properly, the population distribution properly. So if you get a larger number of people in your sample, and if you collect more samples, you're more likely to accurately represent the population distribution, even if you don't have access to the entire sample. So that's basically what a distribution is. It's very important to understand this. It's very important to understand how the z-scores fit and how the raw scores fit along this continuum and what they mean in terms of that continuum. And it's very important to understand that the sample distribution is attempting to be representative of the entire population, and we're trying to infer certain things about the population based on the sample. So that's what we're getting out of this today.